In April of 2026, a team of engineers at NASA's Jet Propulsion Laboratory did something that should terrify you if you think about it for more than 5 seconds. They sent a single command 23 hours into the dark to a machine older than most of their own parents, and they told it to amputate part of itself. Not because it was broken, because it was dying, slowly on purpose, by design, and the only way to buy it more time was to cut away a piece of what made it alive in the first place. That machine is Voyager 1. It is, right now, the most distant object any human being has ever built, and in November of 2026, it will cross a line in space so strange that scientists had to invent a new way of describing it. The point where a radio signal, traveling at the absolute speed limit of the universe, takes a full 24 hours just to get there. S ended a message Monday morning, you get the reply Wednesday. Not because of some glitch, because that is simply how far away it now is. And here's the part almost nobody talks about. This spacecraft was never supposed to see any of this. It was never supposed to outlive its engineers, outlive its own mission plan, outlive the Cold War that built it, outlive the analog televisions its data was first broadcast on. It was given 4 years to live. It has had 49. And somewhere out past the edge of everything the sun protects, it is still talking to us, even as we slowly, deliberately, switch off pieces of its own body just to keep it breathing a little longer. Stay with me, because by the end of this, you're going to understand exactly what kind of impossible bargain is being struck right now, 25 billion kilometers from where you're sitting. Let's go back to the beginning, because the beginning is stranger than people remember. 1977. Disco was on the radio, the Apple II had just gone on sale, and at Cape Canaveral, a Titan rocket lifted a spacecraft built around computers with less raw power than the key fob you use to unlock your car. The plan was almost embarrassingly modest by today's standards. Fly past Jupiter, fly past Saturn, take some pictures, send them home, call it a career. That was it. That was the entire ambition. But buried inside the launch date itself was something the engineers had been quietly counting on for years, a celestial coincidence so rare it only happens once every century and a half. The outer planets had drifted into an alignment that meant a single spacecraft could slingshot from one giant world to the next, stealing velocity from each flyby, like a stone skipping across water. Gaining speed it could never have carried on its own. Miss that window and you don't get a second attempt? Or worse, you wait 175 years for the planets to line up again. So the team built 2 spacecraft instead of 1, just in case, and fired them into a calculation so precise that a rounding error made on a 1970s mainframe could, years later, and billions of kilometers downstream, turn a perfect flyby into a catastrophic miss. Voyager 1 launched second. Within weeks, it had overtaken its twin and pulled ahead into the dark, and almost immediately it did something nobody had asked it to do. It turned its camera backward toward home and captured the first photograph in human history showing the Earth and the Moon together in a single frame, 2 pale companions hanging in nothing. Nobody programmed that moment to mean anything. It just did. It was the first hint that this machine was going to become something larger than its job description. Here is what every scientist on Earth believed before Voyager 1 actually arrived at the outer planets. The farther you travel from the sun, the colder, quieter, and more lifeless everything becomes. Dead rock, frozen gas. Worlds where absolutely nothing happens. Forever. That assumption did not survive first contact. At Jupiter, Voyager 1 confirmed that the Great Red Spot wasn't a stain or a marking. It was a storm, an actual hurricane, wider than the entire planet Earth spinning, with a violence and a longevity that nobody could fully explain even after they'd seen it with their own eyes. It found rings around Jupiter that no telescope on the ground had ever detected. It found moons that had simply been invisible until a machine was finally close enough to look. And then it found something that should not have been possible. On the small moon, Io, Voyager's cameras caught an active volcano in the act of erupting, plumes of material thrown hundreds of kilometers into space, captured live as it happened, on a world that, according to every model of the solar system, should have been a frozen, dead little rock. A moon was on fire, not metaphorically, actually erupting, actually venting heat from somewhere in a place with no nearby sun to warm it. That single image rewrote an entire field of science in real time, because it proved heat didn't need a star. A planet's gravity alone, squeezing and flexing a small moon as it orbited, could keep the moon's interior molten for billions of years. Suddenly, the rulebook for where life-friendly warmth could exist in this solar system had a new and uncomfortable footnote. And then, almost as an afterthought on the way past, Voyager 1 turned its instruments toward another of Jupiter's moons, one called Europa, and found something that stopped scientists in their tracks. A surface cracked and grooved in patterns that looked unnervingly, disturbingly similar to sea ice drifting on Earth's polar oceans. Voyager couldn't see beneath that ice. It couldn't prove anything. But it planted a single, quiet, devastating question into the minds of an entire generation of scientists. What if there's an ocean down there? What if, sealed under miles of frozen crust on a moon? Orbiting a gas giant, there's liquid water. And once that question existed, it never went away. Spacecraft are still being designed right now in 2026, specifically to go back to Europa and answer it. One brief flyby, a few hours of data, and an entire field of human curiosity got permanently redirected. Sit with that for a second, because that's the entire shape of this story in miniature. Something we assumed was dead turned out to be the opposite. If that twist already has your attention, you should know it gets significantly stranger from here, so stay with me. At Saturn, Voyager 1 pulled the exact same trick a second time. The rings, which everyone imagined as a few smooth, simple bands, turned out under close inspection to be an almost impossibly intricate structure. Thousands upon thousands of individual. Ringlets braided with gaps and waves nobody had predicted. Less like hoops and more like the grooves cut into an enormous vinyl record spun from ice and rock. And then there was Titan. Of every moon Voyager ever passed, Titan came back wrong in the best possible way. Not a barren ball of stone, but a world wrapped in a thick orange haze so dense it hid the entire surface underneath. A moon, with weather. A moon where methane does the job water does here on Earth. Flowing, pooling, evaporating, cycling through a complete climate system just built from completely different chemistry at temperatures cold enough to make Antarctica look temperate. To the scientists watching the data come in, Titan didn't look like a dead moon. It looked like a frozen photograph of what the early Earth might have looked like before life ever got started. And Titan was so compelling that mission planners made a decision that, looking back, is almost unbearably dramatic once you understand the stakes. Voyager 1 had the option to keep touring, to fly on toward Uranus and Neptune the way its twin eventually would. Instead, to get the closest possible look at this one. Strange moon. They steered it onto a path that flung it up and out of the flat plane where all the planets orbit, away from everything else in the solar system, permanently. They traded every remaining planet in the tour for one extraordinary moon. That decision ended Voyager 1's life as a planetary explorer. There would be no more worlds waiting downstream, but it began something else. Entirely, something nobody had actually planned for, because Voyager 1 was no longer touring the solar system. It was leaving it. And somewhere ahead of it in the dark was a boundary that an entire generation of physicists had completely misunderstood. For decades, scientists assumed the edge of the sun's influence, the giant bubble of solar wind called the heliosphere, would fade out gradually, the way a coastline dissolves slowly into open ocean. A smear, not a line. Then, in August of 2012, Voyager 1 actually reached that frontier, and it turned out the textbooks were wrong. The change happened in days, not years. Solar wind particles around the spacecraft collapsed almost instantly. Cosmic rays from deep in the galaxy surged upward to take their place. In roughly 48 hours, Voyager 1 crossed entirely out of the sun's domain, as if it had passed through an actual membrane stretched across space. Not a gradual fade, a wall. A real, sudden, measurable boundary where two enormous environments press directly against each other. And here's the part that should genuinely unsettle you. That bubble, the heliosphere, isn't just a line on a diagram somewhere. It's a shield. It blocks a huge percentage of the high-energy cosmic radiation constantly raining in from across the galaxy. Radiation that would otherwise be slamming into every planet inside it, including this one, including you. When Voyager 1 crossed through and found the interstellar magnetic field pressing back harder than every model had predicted, it was quietly telling us that the protective bubble around our entire home might be under more strain than anyone had previously realized. We only know this because one aging machine actually reached the edge and pushed through it. And the instant it crossed that line, it started picking up something on the other side that no human instrument had ever detected before. This is where the story turns genuinely eerie. At Cornell University, a researcher named Stella Koch-Ocker was combing through Voyager's data that had taken more than a day just to cross the dark and land on her screen, when she found a tone she could not immediately explain. Out there in the thin, charged gas of true interstellar space, Voyager 1 was picking up a persistent, low-frequency hum, sitting steadily around 3 kilohertz. Not a burst, not a pulse, not a one. Time event that flared and vanished. A continuous signal sitting in the data for years, quiet, monotone, and utterly relentless. Ocker would later describe it simply as the persistent hum of interstellar gas. And here is why a faint, boring-sounding tone turned into one of the strangest scientific findings of the decade. This isn't a voice. Nobody sent it. It's the natural murmur of plasma waves rippling through the charged particles that fill the space between stars. And crucially, that hum can be measured to calculate exactly how dense that interstellar gas actually is around the spacecraft. Before this discovery, the only way to read the density of that environment was to wait for the sun to throw a violent outburst that would slam into the plasma and make it ring loud enough to detect rare, unpredictable flashes of information separated by long stretches of total silence. The hum changed that completely. It meant Voyager could report on the space around it constantly, on its own, without waiting for the sun to cooperate. For the first time in human history, we weren't theorizing about the medium between the stars from some safe, comfortable distance. We were sampling it directly from inside it, with an actual instrument physically sitting in that environment and reporting back. Think about what that really means. For the entire span of human history, the space between the stars was something we could only calculate, only model, only imagine. No human eye, no probe, no instrument had ever sat inside it and told us what it was actually like. And then one machine, built before most of the scientists studying its data were even born, slipped across that boundary and began sending back the first direct measurements ever taken from that place. The numbers stopped being predictions. They became facts. The galaxy had been humming this whole time. It just took something brave enough and patient enough to go out and listen. Now, here's where this story should genuinely scare you a little, because the machine doing all of this should not, by any reasonable engineering standard, still be alive. Voyager 1 runs on hardware from a vanished technological era. Its onboard memory is smaller than a single low-resolution photograph on your phone. It transmits using less power than a household light bulb across a distance that, by the end of 2026, will be roughly 26 billion kilometers, and it runs on a slowly decaying nuclear power source that has been quietly bleeding away about 4 watts of capacity every single year since launch, with absolutely no way to refuel, recharge, or repair it, ever. The engineers maintaining it have spent nearly 2 decades engaged in a slow, deliberate triage, switching off instrument after instrument, heater after heater, sacrificing capability after capability, just to keep the irreplaceable parts of this machine alive a little longer. As of this year, only 2 of its original 10 science instruments remain functioning. In April of 2026, mission engineers made the decision to power down the low-energy charged particles experiment, an instrument that had run almost continuously since 1977, nearly 49 years, because the spacecraft's voltage had dipped unexpectedly during a routine maneuver, and any further drop risked triggering an automatic shutdown the team might not be able to recover from. So they cut a working, functioning, historically valuable instrument loose on purpose before the spacecraft could be forced to do something worse to itself. That decision wasn't made in a panic. It was made years in advance. An agreed sequence the team had mapped out long before anyone had to actually pull the trigger, a list of what gets sacrificed and in what order, so the heart of the machine can keep beating just a little longer. And now they're attempting something even bolder, a plan internally nicknamed the Big Bang, an enormous one-time power reconfiguration designed to free up enough energy that the mission might stretch even further, possibly even allowing some shutdown instruments to be switched back on later. They tested it first on Voyager 1's twin, the safer, slightly less fragile of the two, in the spring of 2026. If that test holds, the same operation gets attempted on Voyager 1 itself, no earlier than this coming July. Think about the sheer audacity of that. Engineers on Earth sending a single, irreversible command across a gap so vast that the confirmation of success or catastrophic failure won't arrive for nearly 2 full days, to perform major surgery on a patient they can never see, never touch, and can never go back and fix if something goes wrong. And this isn't the first time the team has had to perform something close to a miracle. Rewind to late 2023, when Voyager 1 abruptly began transmitting nothing but garbage. A stream of meaningless, corrupted data, the result of a memory failure buried deep inside its flight data system. The spacecraft was still talking. It had simply stopped making sense, like an old mind quietly losing its words mid-sentence. Suzanne Dodd, the Voyager project manager at JPL, was blunt about the odds. It would be, in her words, the biggest miracle if they got it back. At that distance, every single attempt to even diagnose the problem cost the better part of 2 days of silence. No way to know if the patient on the other end was even still capable of being saved. So her team did something that sounds almost insane when you say it out loud. They rewrote the operating software of a computer, designed in the 1970s. They sliced the necessary code into pieces small enough to physically fit, inside memory that was already failing. They deleted old, unused routines, including leftover software from the spacecraft's 1979 flyby of Jupiter, simply to make room. Most of the engineers who originally built this hardware had long since retired. There was no spare part to swap, no technician who could be sent out to fix anything by hand, just a sequence of commands, fired into the dark, that had to be flawless on the first try because there would barely be room to attempt it twice. And then there was nothing left to do but wait. In the spring of 2024, the team gathered in a conference room at JPL to find out whether it had worked. The garbled noise resolved suddenly into clean, readable data. The room broke into a cheer. Project scientist Linda Spilker called it simply a great day for Voyager 1, because they were finally talking again. A machine built before the internet existed had just survived brain surgery performed across interstellar space by people who could never lay a single physical hand on it. And through every single one of these crises, this spacecraft has been quietly carrying something that has nothing to do with science at all. Bolted to its frame is the Golden Record, a gold-plated disc filled with sounds and images and music gathered from across human civilization, assembled by a committee led by the astronomer Carl Sagan. Nobody seriously believed, even back then, that any alien intelligence would ever find this thing and know what to do with it. The odds against that are almost beyond calculation. It was placed there anyway, because humanity decided that if something of ours was finally going to leave this solar system forever, it should carry proof that we existed. Rain, thunder, ocean surf, music pulled from cultures across the entire planet, greetings spoken in dozens of languages, the recorded sound of a mother speaking gently to her child. All of it bolted to a machine now drifting permanently away from everything that ever made those sounds matter. And because this spacecraft will almost certainly outlast every monument and every building and every written record humanity has ever produced on Earth, that small golden disk may end up being the single longest surviving trace of our species anywhere in the universe. The people who built it knew, almost certainly, that no one would ever find it. They built it anyway, not for an audience, because the act itself meant something. It turned a scientific instrument into something closer to a messenger. So understand what is actually happening right now in real time as you watch this. In November of 2026, Voyager 1 crosses the 1 light day mark, a 250,000 mile per minute, 49-year journey finally arriving at a distance so vast that a simple good morning sent from Earth takes a full day just to reach it, and the reply takes another full day to come home. The spacecraft is still out there, still listening to a hum no human had ever directly measured before it arrived, still carrying a message in a bottle thrown into the largest ocean that exists. And it is doing all of this while its own engineers are forced year after year to cut pieces off it just to keep it breathing. By most current estimates from the team at JPL, the available power will likely drop below the threshold needed to run any instrument or even maintain a basic radio connection sometime in the early 2030s. When that happens, this machine will not stop moving. It will not stop existing. It will simply go silent, and then it will keep traveling outward, carrying the golden record deeper into the galaxy, forever, long after every person who built it, repaired it, and listened to its final transmission has passed away themselves. There is something almost unbearably moving about that. A machine built in the 1970s, with less computing power than a modern wristwatch, has already outlived its own death sentence by more than 4 decades, and the people keeping it alive right now know, with total certainty, that one day very soon they will send a command and simply never hear an answer come back. And they keep going. Anyway, they keep listening anyway, because somewhere out past the edge of everything the sun protects, there is a hum in the dark that no human being ever heard before this machine went out and found it, and as long as it can still speak, somebody on this planet is going to keep listening. What do you think we'll learn before Voyager finally goes quiet for good? Tell me in the comments, because I genuinely want to know what you think is out there. And if this is the kind of story that makes you look up at the night sky a little differently, subscribe, because there's a lot more like this coming.